We really are running more on time than we even need to be, which is unusual for a conference, but that's because we're all running on ketones. We're going to bring up Dr. Ali now, and he's going to talk about understanding autophagy, cell repair, renewal, and remodeling. So let's welcome Dr. Ali.
It's an honor to be back in New London again, renewing friendship. And I couldn't be happier that Megan laid the foundations for my talk. Because autophagy is something that is so important that I have been completely fascinated by it. So when I want to give you a metaphor for autophagy as to what autophagy is. Like, let's say you you're in the habit of eating constantly and cooking constantly. Your kitchen would look dirty. It'll have all kinds of junk around it. So here is how your kitchen would look like if you don't clean. And if you're cleaning it, it'll look better. So constantly eating and feeding yourself is a situation in which you're not performing self-cleaning. Sometimes, despite the fact that you clean the kitchen quite well, there's a little grime left that you cannot remove. The stuff doesn't work, the burner doesn't work as well, the cabinets are loose. And you got to do a deeper cleaning or you got to do remodeling. So that's what autophagy is all about. I've put a picture of a cell. We are made of trillions of these cells. And I'm pointing out to the mitochondria, which is the energy burning part of our cell. That's the engine of the cell. And the endoplasmic reticulum, which is where you make protein. That is the protein making factory. And then the subject of our talk, which is the lysosome. The lysosome is the recycling center. So as we get older and as we practice the standard American diet, our organelles, the small protein making factory in our body, it gets older, it gets swollen up, it doesn't function as well. The mitochondria, which are the engine, they start spewing out oxidative damage, which is just another way of saying that they create too much fire. So all of these organelles need to be repaired. Now, Megan talked a lot about protein. Now, protein is very important to give us structural integrity. And the protein has to be shaped in a certain way. When you are making protein through damaged protein manufacturing endoplasmic reticulum, that protein is misfolded. And a misfolded protein doesn't function as well. It needs to be cleared out. And if you don't clear it out, it aggregates. These aggregates can sometimes become filaments, and if these filaments become permanent, then they are called amyloid. So my wife has all of these cleaning mechanisms in her kitchen: water, scrub, soap, all kinds of recycling bags, and a recycling center. And similarly, our cell has excellent recycling mechanisms. So recycling is initiated. If you look at the top right-hand corner for you of the slide, there is a set of proteins that recognize that cleaning needs to happen. These are called autophagy initiator complex. And in my house, it's my wife who's the initiator. What she does is that she gives me a garbage bag and says, hey, take this garbage bag and go and pick up all the stuff in the kitchen. So really what's happening is that a garbage bag is formed in the cell, and that's called the phagosome, and it goes and picks up senescent organelles, protein aggregates that our cell does not need and needs to clear, and it takes it to this recycling center that's called the lysosome. And the lysosome is just not a trash disposal. It is much more than that, because what it is doing is that it is breaking down the protein into amino acids. It is breaking down rancid fat to fatty acids. and recycling them to new protein and new cell membranes. This slide is meant to convey to you that the initiator complex is very important, and it's under the control of something called mTOR. mTOR is a protein that goes and binds to this initiator complex, and it prevents it from activating autophagy. So conditions of nutrient excess, if you're eating all the time, if your insulin levels are high, if you're making certain growth factors that are insulin dependent, like insulin-like growth factor, there is a tight coupling of the mTOR to the autophagy complex, and you don't, to the autophagy initiation complex, and you don't perform autophagy. On the other hand, in order to initiate the cleaning mechanism, you need to dissociate the mTOR from this complex, and you can do that by the mechanisms of fasting and exercise. So I stole this slide from Professor Ushumi. He won the Nobel Prize for defining the mechanisms of fasting back in 2016. And he takes a 60-kilogram Japanese male, and he says a Japanese male at 60 kilograms will have 9 kilograms of muscle mass. And every day, this person is breaking down 240 grams of protein and making 240 grams of protein. I never thought about it that way, but when you think about it that way, it makes sense that a person eats only 70 grams of protein per day, a 60-kilogram man, that's about the protein he would eat. So where is the other 170 grams of protein coming from to remake the protein? And it's coming from recycling. It's coming from taking out dead protein that our body has. In fact, this recycling mechanism is so important that our body replaces its entire protein in 3 years. So, not to get daunted by the slide, there is not just one mechanism of autophagy. I'd be able to get only into 2 mechanisms today. My Twitter feed is filled with different types of autophagy. You can go and look at that. But this is an especially interesting mechanism. It's called chaperone-mediated autophagy. And what that really is that there is a set of chaperone proteins that recognize dysfunctional proteins, misfolded proteins, protein aggregates. It picks it up and brings it to the recycling center. And when it brings it to the recycling center, the analogy I want to give to you is that my wife says, hey, you didn't clean the kitchen well. Here is this Dyson vac. There are those breadcrumbs out there. Go pick them up. So it's much like taking a Dyson vac and picking up these protein crumbs in your cell, bringing it to the recycling center. And the recycling center has a certain protein, which is called LAMP3. So in order to tell you what LAMP3 is, just nothing like but an incinerator. So you put the junk into the incinerator and it just washes it off, but it's a little bit better than that because it takes the protein into the lysosome, it breaks it down into amino acid and reuses it. So it's not just aerating, but it's also recycling. Why is this so important? The reason it's important is that the reason our brains age is because of protein aggregates. So clearing the protein aggregates in our brain is one of the fundamental mechanisms of remaining young and not getting Alzheimer's. And if you are not activating this form of autophagy, you will get plaques and you will get dementia. In fact, the amyloid is a protein aggregate that is happening because of lack of autophagy. Similarly, if you have Parkinson's disease, you get a different kind of protein aggregate called the Lewy body, and so on for Huntington's disease and for ALS. So this is work of Dr. Mark Mattson. He's at the National Institute of Aging, and he says that autophagy in the brain is highly important for 2 processes. The first process is neurogenesis. You form new brain cells if you are clearing out the dead stuff. The other reason why autophagy is important is for what is called synaptic plasticity. So each neuron communicates with another neuron through these dendrites, through these finger-like projections. And the neurotransmission is happening between these connections. What is shown on the middle of the slide is a dendrite, is a nerve ending that is healthy. It has been doing autophagy. The mitochondria are better. They are numerous. You see the garbage bag phagolysosome that is moving towards the center of the cell so that the cell can eliminate dead debris. Whereas the one on the extreme right is showing that there are fewer mitochondria that are dysfunctional. The phagosome, the garbage bag, is more towards the periphery and not being cleared. So this is not capable of good neurotransmission. A similar group has done work on rhesus monkeys. They've taken rhesus monkeys and they have calorie restricted them to 30% of what a control monkey ate. And it's fascinating to see their brains. Their brains have preservation of gray matter. Their neurotransmission is better. And this group postulated that the reason the rhesus monkey with calorie restriction was able to retain the brain function is because of mechanisms of autophagy. So there are two other concepts that I want to get into. One of them is called apoptosis, and the other one is necrosis, in which you have cell death. So on your right is a room that is sort of disorganized, dysfunctional, and I think only a mother can clean that room. But sometimes even they give up. On the right is a sort of a situation which is toxic disorganization, which you will say, this is not salvageable. So in the first situation, you would board up the house and do a controlled destruction. On the other side, you'd say, no, this should be bulldozed. So this is showing you necrosis. Necrosis is a cell as it ages, as you are doing the standard American diet, it swells up, the protein-making machinery is not functioning well. You can repair that by promoting autophagy, but if you don't, and there is persistent injury, the cell dies, it spills its contents into its milieu, inflammatory cells come in and cause inflammation. On the other hand, if the cell is to die, but it is not as injured and you're practicing autophagy, the cell shrinks, it breaks up into small pieces, it's picked up by the macrophages without inciting inflammation, and that is apoptosis, which is programmed cell death. So now, so far I have told you about autophagy, and now you're saying, what starts autophagy? And there's a lot out there on the internet that says, hey, you can have apple cider vinegar, green tea, you can eat certain kinds of protein to activate autophagy. And I want to tell you that there's probably very little evidence for that. What I want to do is to use a tagline from Smith Barney, which says, they make money the old-fashioned way, they earn it. So you have to earn autophagy by fasting. And like Megan said, long-term fasting is better than short-term fasting. You got to earn autophagy by reducing your carb intake. Low-carb diet reduces insulin, that helps. Exercise is an important way in which you cause nutrient depletion, and I will get into the weeds of that a little bit more. Now, what happens as we get older? As you get older, there's a continual decline in your autophagy. It's coming down. And if you are accelerating it by eating a standard American diet, it's going to come down even faster. On the other hand, if you're practicing autophagy, if you're practicing a low-carb diet, autophagy comes down much slower, and you can intersperse that with periods of fasting and exercise to prevent that decline. So what evidence can I give you from animal studies? So this is a rat study. Fisher rats were taken. They were divided into 4 groups. A group that was studied at 7 months, but given all ad libitum food and kept sedentary. Second group, at 28 months, sedentary, given all the food that it wanted. And a third and fourth group that were studied at 28 months, but they were calorie restricted only by about 8%. And the fourth group was exercise, the third group was kept sedentary. Now what I have shown you is that there is this garbage bag disposal mechanism of autophagy. It forms this garbage bag which is called the phagosome, and you can identify the phagosome by a specific protein which is called LC3. So the goal of the study was to find out which group of animals had the highest presence of LC3, and the group that had the highest presence of LC3 was the group of animals that were calorie restricted and exercised. Now, what about the chaperone autophagy, the lamp protein, the insyncerator that I talked to you about? Which group of animals had the highest induction of chaperone-mediated autophagy? It was again the group of animals that were calorie restricted and exercised. Now we talked about that mitochondrial health, the engine of our cell, is highly dependent on autophagy. If you're not practicing autophagy, the mitochondria get diseased. When they oxidize something, they create a lot of fire. That's called oxidative damage. In the middle of the slide are mitochondria that are healthy, and when they burn fuel, they don't create as much fire. Now you can measure the degree of oxidative damage by checking something called 4-HNE, and the group of animals that had the least amount of oxidative damage or production of fire was the group that exercised and was calorie restricted. Now we talked about apoptosis, which is programmed cell death. You don't want that. You want the cell to have autophagy so that it can repair itself. Which group of animals had the lowest amount of apoptotic index, lowest amount of programmed cell death? It was again the group of animals that were calorie restricted and exercised. Now moving on, I want to talk to you about a human study. So they took 11 people who were ultra endurance runners. They would run for 24 hours. I don't know why anybody would want to do that. In 24 hours, they covered 150 kilometers. They were not able to eat as much as they were burning. In fact, they could only take about 30% of the caloric needs. And as Megan pointed out, we have a robust machinery to make sugar. We are not eating sugar, but we can maintain sugar. So over a 24-hour period, their sugars did not go down. But their insulin levels did fall. Now, as you're exercising, you use energy currency. Energy currency in our body is called ATP. So ATP gets broken to ADP by giving a phosphate molecule an energy that the cell uses, and then it finally becomes AMP. So when you have AMP, you activate something called AMP kinase. Now AMP kinase is a master regulator of autophagy, because when AMP kinase levels go up, it increases the garbage disposal mechanism. It reduces the activity of mTOR. So they took these individuals and then did muscle biopsies before and afterwards to show that AMP kinase activity was increased by about 250% in these after exercise. That the activity of mTOR, the one that blocks autophagy, was decreased by 30%. What about the garbage disposal mechanism, which is the LC3 protein? So the LC3 protein picks up, it forms the autophagolysosome. It had gone up by more than 500%. Now this is another study in which they took trained athletes, well-trained athletes, divided them into 3 groups: a sedentary group, a low-intensity group, and a high-intensity group. So to the sedentary group, they didn't exercise them, but to the low intensity, they made them do this unthinkable thing of making them run for 2 hours on a treadmill at 50% of their maximal oxygen consumption or at 70%. And they were studied both in fasted and fed state, and muscle biopsies were done at various different time points. What happened? Now, when you look at the activity of AMP kinase, and they measured a surrogate of that, the group that did high intensity exercise had the highest activation compared to the sedentary group. Fasting or feeding did not seem to make a difference. What about the garbage type mechanism, the autophagolysosome, the LC3 protein? Which group had the highest autophagy out there? It was again the high intensity group compared to the low intensity or the sedentary group. Fasting or feeding in the study did not make a difference. Now, autophagy does many different things, and one of the functions of autophagy is to fight invaders. If you have robust autophagy, the bacteria are taken in by the phagolysosome. It's given to the lysosome, which has got powerful enzymes to destroy the bacteria. And it is not only good for common bacteria like strep, but it also is important for reducing TB. Now, I wanted to take a few extra minutes to tell you a very important concept that Megan brought up, and that is called glucose-induced substrate hysteresis. And I'd like your indulgence because I want to read this slide out, that there is asymmetry in the ease of metabolic adaptation towards sugar versus fat. The longer the body favors glycolysis, which is sugar burning, the harder it is to switch to fat burning. Metabolic flexibility is progressively and irreversibly lost with age and is accelerated by the standard American diet. Perhaps this loss is because you're losing chaperone autophagy, and I want to get into the weeds of that a little bit. So now this is a glycolytic pathway. This is the pathway through which we burn sugar, and I don't really even want you to look at it. The only reason I put it up there is because it's got so many different enzymes. I want you to focus on this slide, which is that when you lose the chaperone autophagy, your glycolytic enzymes get upregulated, so you're only capable of burning sugar. You are gluconeogenic. Our body is capable of making all the sugar it needs, but you downregulate that mechanism. You downregulate the mechanism for burning fat. So what is happening here is that you are reducing a specific kind of autophagy. What you are doing is that you're capable of only burning sugar. So if somebody is metabolically unhealthy, he comes to you and you say, hey, take this low carb diet. And that person comes back and tells you that I've been practicing it, I've been getting no benefit. Rather than like every other doctor tells you that you are morally deficient, you're not motivated, maybe this person has lost his mechanism to burn fat. And he may need to consult with Jason and Megan because reactivation of these enzymes would require a prolonged period of fast. So I love the podcast that Carl and Richard have in which they talk about the things that they got wrong. So I've been practicing for about 5 to 6 years in low carb. And what I got wrong was my insistence to my patients that they should fast for no longer than 48 hours because I was scared, like some other groups, that fasting for longer than that, you would be losing protein mass. Little did I realize that you're not losing really biceps and muscles. What you're losing is junk protein. And when you fast for prolonged periods of time, there is a pulsatile increase in growth hormone. In fact, the whole weightlifter community, the muscle building community is so fascinated by autophagy that they try to activate it in every possible way. So the question that comes about is that, how long do I need to fast? So the answer to that is it depends. How insulin resistant you are, how obese you are, Are you following a standard American diet? Do you have unhealthy fat cells? Unhealthy fat cells are seen when your triglycerides are high and when your good cholesterol is low. That is not the situation with lean mass hyper-responders. Is there inflammation? Are you old? Because when you are old, your autophagy mechanisms may have gone down, and you may need, and I was happy with a 3-day fast, but talking to Megan, these people might need a 7-day fast. On the other hand, if you look like this, you are insulin sensitive, you can make ketones easily, you are doing a low carb diet, you have good quality cholesterol, in other words, your fat cells are healthy, that you exercise, you have less inflammation, you're young, you can perhaps initiate autophagy within 1 day. Now, there are some populations in which you need a prolonged fasting in order to activate autophagy. And these are people who are insulin resistant, who have unhealthy fat cells as shown by high triglycerides and low HDL, who have inflammation, who have high blood pressure, and who have neurodegenerative disorders in their early stages. Insulin is important because insulin binds to mTOR, and when it binds to mTOR, it prevents autophagy. So high insulin state means that you need to bring it down with prolonged fasting. Unhealthy fat cells are fat cells that cannot take any fat in, so fat increases in the bloodstream as triglycerides. And unhealthy fat cells die, they attract macrophages, which is inflammation. And when you have inflammation, you are activating mTOR, and you are preventing autophagy from happening, and you're not doing any of the cleaning mechanisms that autophagy is meant to do. Now, high blood pressure is a special situation. In high blood pressure, it is the brainstem that is increasing a sympathetic response. It's the fight or flight response. It's the adrenaline response. It increases your blood pressure. It increases your heart rate. It drops your heart rate variability. On the other hand, if the brainstem is going through autophagy, it has the parasympathetic response. It's mediated by a nerve called the vagus. It drops your blood pressure, drops your heart rate, increases your heart rate variability. But it is the sympathetic response that activates the mTOR. It prevents autophagy. So prolonged fasting is important, but I think it should be medically supervised. You need to talk to Megan or one of his colleagues because you need to adjust your blood pressure and diabetic medications, much as she pointed out. You also need to learn how to measure sugar and ketones, and perhaps refeeding should be better organized. Not practicing autophagy is like never upgrading your car. You have never enjoyed the benefits of Bluetooth, of GPS, of adaptive cruise control, of self-driving features. So in conclusion, what you're doing with autophagy is that you're removing rancid fat. You're removing dead protein. You're removing senescent organelles through this beautiful mechanism that our body has created, because we have nutrient excess in this world. Our ancestors didn't have a fridge and a supermarket. They were forced to go through autophagy. We aren't. And when you do that, the body is not just self-eating. It's not just cleanup and disposal. It is recycling, it's repairing, it's remodeling, it's preventing infections. And by doing that, it's also reducing cancer risk, something that we could not get into detail. So all of these benefits are happening to you in terms of the cleanup mechanisms. And when you do that, what's going to happen is that you're going to reduce your blood pressure, one of the best ways to do it, reduce your heart rate, increase heart rate variability, which is a good thing. You're going to improve your cholesterol quality. You're going to improve your insulin sensitivity. You're going to reduce inflammation, and that's what's going to prolong longevity. The chaperone-mediated autophagy needs a slightly different conclusion because it's extremely important for our brain health. And in order to prevent neurodegenerative disorders, The CMA, as it is called, may need exercise and more long-term fasting according to the studies, and may not be started or activated by short-term fasting. So what do? I say that a lifelong of a ketogenic or a low-carb diet is a good thing, that several days a week an 18-hour fast with a 6-hour feeding interval is good, that movement and exercise is important, but I have firmly moved over into the Jason Fung and Megan Ramos camp by saying that you need 2 to 3 times a year in which you need to do a prolonged fast in order to robustly activate your autophagy mechanisms. And my tagline is that promoting the biologic mechanisms of autophagy is the defining opportunity of our time to improve human health and prolong longevity. So thank you.